these maps here show sort of an overview of the knowledge we have. The left one is the geological maps that we've made in the past. The dark blue areas is where we have some sort of cover with sensors, like a sonar cover map. And the areas in between are, I like to call it geopolicy areas. And in the middle, you see a map of where we have full coverage data with sonars from the Maritime Administration and a little bit from us as well. So the green areas is where we have high resolution data in the ocean. And you can see that along the coast, there's this sort of ribbon, lots of areas where we don't have good data. But in the offshore areas, there's actually quite good cover. Altogether, it's almost up to 70%. Then we are still struggling with getting access and using that data. We'll talk a little bit more about that. But we have some information. And then on the right, that's sort of showing this program and the activities and the mapping that has been done. Essentially, this started 2016. There was a pot of money for mapping that went through SWAM, and there was a number of activities. There was modeling of species on the county levels that consultants were doing, and there were some drop camera service on different places. There's also been some work on different iterations of depth models to support modeling. And we got into this program to also bring in the perspective of high resolution mapping at first. So going to areas where we essentially don't know anything, and we put also our vessel in there, and we made something similar like in the Seabot, but for these offshore bank areas. So Hobart's Bank in the North Mid-Sea Bank that we knew they're the areas a little bit south of Gotland, where we knew there were high nature values but very poor data. So we wanted this to be a part also to contrast the modeling done with existing data. We wanted to also get a view, how does the seafloor look like when we have the best available data, and how does that compare with the values of modeling efforts. And then now in the end, we've also added a component where we started to do national substrate models as well, where we've been able to use the data from the Swedish Maritime Administration and start doing higher resolution models on the national scale. So I'll show you a little bit about that work specifically now. And I should also say that this first part of the program, where it's been a lot of different kind of pilots and testing, it's sort of wrapping up this year, and with some activities to finish some of the county level models for species that we're not doing, but we're doing some drop camera surveys this summer to support that work. But we're also trying to go forward at the next phase and applying for money now, where we're going to try to bring everything together to be a little bit more integrated, so that all the data feeds into, all the efforts feed into the same databases and build knowledge in a little bit more integrated way than we did in the past. So I just wanted to show you the main work that we did. The left side is these areas in the harbor porpoise marine protected area that is south of Gotland. That's still going to do a management plan and so on. And we did 2 patches that had really poor data, and we did everything we could there. I will show some of that. And then on the right there, this is the national models. So if we start with this, again, a similar kind of pilot, but this time 1,400 square kilometers, so quite large. We collected very high resolution data on everything. We had really nice cameras and sensors, and we looked down in the sediments and we took samples. And we had SLU on board doing some fishing as well, so we had some good fish for lunch, some parts of the field trips. This is part of sort of this revolution, is that these really high resolution images that are well positioned on the seafloor makes us able to capture the patchiness in these areas. So this covers about 15 square meters, that whole image, but we focused on the best resolution part. And we did percent coverage both on geology and species. And we complemented that with sediment samples for the grain sizes that we can't see in images. And as you see, the resolution is quite nice. And by connecting, I'm not going to go into the details today, but by connecting that with the high resolution survey data, where we have both the sonar mosaics, backscatter, and also high resolution bathymetry down to 0.5 meter, we were able to really capture this in the models also. This is coverage of sand, so percent coverages. And we started by building subset models, and we added expert interpretation, and then we build the biological models on top of that. So this is without any, this is lower resolution data. And then we add higher resolution depth with no backscatter. It's essentially sonar mosaics from the seafloor. And then when we add this, you can see that the percent coverage of mussels and the whole area goes up for every step. In this last model, we used expert knowledge and fixed the subset model so they're as good as possible before we make that biological model. And the nice thing here is that by doing this, we were able to capture the really hard difference between flat areas with sediments on and flat areas with hard bottom. It's really hard to make this distinction in these areas. So it makes a big difference in the aerial coverage. And also in these kind of mapping activities, we do find these kind of small, patchy, special places. So on the North Mid-Sea Bank, we found spawning sites for herring, and they were very specific, very small, isolated little reefs. And once you knew what you were looking for, you can almost say it's going to be one of these areas. This is a small hard clay reef there in the middle of a sandy area that was filled with spawning with eggs. This is also an area where a lot of the harbor porpoises have been located. So quite interesting. So of course, this takes a lot of time, effort, money, and you cover like 2% of Sweden when we did this exercise, 1 or 2%. So it's very nice, of course, you can do more national models. This is just, again, some work in progress outputs from the ongoing effort to do substrate models on the national scale. And they are very much more detailed than an old geological maps we had. So it's very nice to see them. They capture lots of good patterns and lots of new hard bottom areas that we didn't have maps on before. So a lot of good work going on. But it's also very challenging because we need to have good predictors, good environmental data to be able to do that. This is one area in the bottom sea where you can fit Gotland in, and there's only like 36 depth measurements in that whole area. So obviously makes it challenging to make good models. So this is where mapping comes in. This is eventually going to be mapped by Swedish Maritime Administration. And then we use, also this is the density of data with observations like samples or photos. And so we spent a lot of time building depth models, and this is one of the core items for this, trying to make the most out of the data. So it's a very nice thing that was recently just finished. But just to recap a little bit, this is focusing on Hobart's Bank, a fairly large patch there. And here you can see the difference between the high resolution mapping models and the national models showing the same parameters. And essentially, for some of these patchy areas, it's almost impossible from only depth data, even at 10-meter resolution, to see if it's hard or soft bottom. And when we go in and we have the really nice data on the left, we find much more specific reefs, more special places, and we are able to do this hard distinction between hard and soft. So this is really good knowledge to use when we try to understand the value of maps and what they do and what they don't. And then I just wanted to show you a little bit of fly through on the new bathymetry model in the Botnian Bay, because it's nice. And you can see some of the complexity that's down there that we currently don't really capture. In the lower resolution model, this is all soft bottom, but that's probably not true in reality. Sorry, I had to record a screen in PowerPoint, so the resolution of the video got a little lowered. But there's so much interesting features that are down there, and lots of structure, lots of. It's quite phenomenal. And when you see on the right there, you see the low resolution depth model, you don't see anything. And what happens here in the end is that this is the territorial border, and inside that, all the data is more or less secret. So this is a very big challenge that we work with. And this is the CMOD area. So anyway, that's all I had to say about the mapping program. So I think we have done some really nice progress, and that in the future we will keep bringing all this information together and getting a more collaborative platform in Sweden. Anyway, thank you.